Moving to next one. Fourth question. A car driver sees a hazard on the road ahead. The graph shows the velocity of the car from when the driver sees the hazard. Use the graph to determine the reaction time of the driver. Now the reaction time is where you can see this graph is not changing. The velocity value is not changing, because while we react, the velocity stays constant. So you can see that value is less than 1 second. So, and also it is in between this line. So it has to be 0.9 second. Then next one, calculate the stopping distance of the car. To calculate the stopping distance, we will have to use the area under the graph. So we will write down distance equals so this counts 1 mark. Next one, we will substitute. So stopping distance means the addition of thinking distance and break-in distance. That means we'll have to consider this whole trapezium. To consider that, first of all, this is the height. So that is 15. This side it is 4. This is 0.9. So we will consider those values and add. If you want, it's better here to write down stopping distance equals if you want, you can add and show it separately, or you can directly find out half. I would take the values here 0.9 and 4 plus 4 seconds multiplied by 15. Once you do this calculation, answer will be 36.75. If you want, you can round it to 37 meters. Moving down, calculate the acceleration of the car when the car is braking. Now that means you can use a graph to find out it from the gradient, or you can find out by using the equation. Final velocity is anyway 0. Divide by initial velocity is 15. Time taken is give me 1 second. Here it is 4 minus 0.9. Has to be 3.1. So the answer will be minus 4.8. So here, once again, when you are writing the value, it has to be minus 4.8 meters per second square. It has to be minus because it's a deceleration. So here they have said acceleration and you have to write it as minus. By any chance, if they have given deceleration over here, you can just directly write the value without the minus sign. Next question, the speed of the car affects the thinking distance and the braking distance. Discuss other factors that affect the thinking distance and the braking distance of the car. Now this question is easier because they only say that how this is affecting on the thinking distance or the braking distance. They don't say whether the distance increases or decreases. If they say specifically, it would be a little bit harder. And also they are talking about both thinking distance and braking distance. So you can talk about all the factors which is affecting on increase in the stopping distance. So we can say, first one, if you think about the thinking distance, first we can say if the person is tired, tiredness of the driver. Or you can say age of the driver. Or you can say whether alcohol consumption, or you can say the distraction. And next you can talk about the braking distance, how the factors are affecting on the braking distance. Mass of the car or the weight of the car. Then you can say the condition of the brakes. And also you can say the condition of the roads. You can say condition of the tires, like that. Now here, for an example, like the condition of the road, we have discussed that if it is an icy road, definitely the friction is less, so that there will be more braking distance, like that. They are not exactly asking whether the distance increases or decreases, so you don't have to specifically mention which type of condition has to be there. But somehow you have to write at least 2 points from each of these